We've come a long way from the days of tin cans and string. Remember when the only way to communicate over long distances was by sending letters? Then came the telephone, and suddenly we could hear voices from far away. But it wasn't until the launch of Sputnik in 1957 that we realized the true potential of space for communication. That's right, satellites have revolutionized the way we connect with each other. From making phone calls to browsing the internet, satellites play a crucial role in our daily lives. They're like giant mirrors in space, reflecting signals back down to Earth. The first communication satellites were pretty basic. They could only handle a limited number of signals, and coverage was spotty at best. But over time, scientists and engineers have made incredible advancements. Today, sophisticated satellites orbit our planet, providing us with global coverage and lightning-fast communication speeds. In this essay, we're going to explore the fascinating world of satellite communication. We'll learn how these systems work, the different types of satellites in orbit, and how new technologies are shaping the future of global connectivity. Get ready for an out-of-this-world adventure. Imagine a world without GPS, satellite TV, or even reliable long-distance phone calls. That was the reality before communication satellites came along. Early communication systems relied on cables and radio waves, which had their limitations. Cables were expensive to lay down, especially across oceans, and radio waves couldn't always reach distant locations. Enter the satellite. These technological marvels provided a way to bypass these obstacles and beam signals directly from space. The first communication satellite, Echo 1, was launched in 1960. It was basically a giant balloon that reflected radio waves back to Earth. While primitive, it demonstrated the potential of using satellites for global communication. Soon, more advanced satellites were launched, capable of receiving and transmitting signals. Telstar One, launched in 1962, relayed the first live transatlantic television signal, marking a pivotal moment in history. These early successes paved the way for the development of more sophisticated satellite systems. However, these early systems had their drawbacks. Coverage was limited, and satellites could only handle a small number of signals. To access satellite communication, you needed large and expensive Earth stations. So, while these early satellites were a major technological leap, they were far from perfect. They did, however, ignite a spark that would lead to the development of the global communication networks we rely on today. As the demand for communication grew, so did the need for wider satellite coverage. Imagine trying to make a phone call from the middle of the ocean or access the internet from a remote village. Global coverage is essential for connecting people in even the most far-flung corners of the world. It ensures that everyone has access to information, communication, and vital services, no matter where they are. Achieving global coverage is no easy feat. It requires a constellation of satellites strategically positioned in orbit around Earth. These satellites work together to create a seamless network that can relay signals across vast distances. By launching multiple satellites into different orbital paths, engineers can ensure that there's always a satellite within range of any point on Earth. Global coverage has become increasingly important in our interconnected world. It enables us to stay connected with loved ones, conduct business across borders, and access information from anywhere. Whether you're a scientist conducting research in Antarctica or a traveler exploring the Amazon rainforest, satellite communication keeps you connected to the rest of the world. And as we continue to push the boundaries of technology, global coverage will become even more crucial in bridging the digital divide and creating a more connected future. Section 4. Geostationary versus non-geostationary. Different orbits, different uses. Not all satellites are created equal. In fact, there are different types of satellites, each designed for specific purposes. Two of the most common types are geostationary satellites and non-geostationary satellites. Understanding the difference between these two is key to grasping how global coverage is achieved. Geostationary satellites orbit Earth at a very high altitude, approximately 36,000 kilometers above the equator. The unique thing about geostationary satellites is that they orbit at the same speed as Earth's rotation. This means that from our perspective on Earth, these satellites appear to stay in the same spot in the sky. This fixed position makes them ideal for applications like satellite TV and weather forecasting, where continuous coverage of a specific area is crucial. On the other hand, non-geostationary satellites orbit at lower altitudes and don't maintain a fixed position relative to Earth. They move across the sky, which means that they can provide coverage to different parts of the planet at different times. While they don't offer continuous coverage of a single area, their lower altitude makes them suitable for applications that require lower latency, such as internet connectivity and GPS navigation. Section 5. Ground Control to Major Tom. The importance of Earth-based systems. Satellites may be the stars of the show when it comes to global communication, but they can't do it alone. Just like a rock band needs a sound system to amplify their music, satellites need Earth-based systems to transmit and receive signals effectively. These ground stations act as the crucial link between satellites in space and users on the ground. Earth-based systems consist of antennas, transmitters, receivers, and other equipment that allow us to communicate with satellites. These stations are strategically located around the world to ensure coverage and reliability. When you make a call, browse the internet, or watch satellite TV, your signal is first transmitted to a ground station. The ground station then beams the signal up to a satellite, which in turn relays it to another ground station, or directly to your device. These Earth-based systems are essential for maintaining the quality and reliability of satellite communication. They amplify signals, filter out interference, and ensure that data is transmitted securely. As technology advances, ground stations are becoming more sophisticated, enabling faster data speeds and greater bandwidth. Without these unsung heroes of the communication world, satellites would just be expensive pieces of metal orbiting our planet. Section 6. The future is now exciting new technologies for global connectivity. The world of satellite communication is constantly evolving, with new technologies emerging all the time. From miniaturized satellites to laser communication systems, the future of global connectivity is looking brighter than ever. These advancements promise to revolutionize the way we connect, communicate, and access information, no matter where we are on Earth. One exciting development is the rise of small satellites, often called CubeSats. These tiny satellites are much cheaper to build and launch than traditional satellites, making it possible to deploy large constellations for wider coverage. CubeSats are being used for a variety of purposes, including Earth observation, scientific research, and even internet connectivity in remote areas. Another game changer is laser communication. While traditional satellite communication relies on radio waves, laser communication systems use beams of light to transmit data. Laser communication offers significantly faster data speeds and is less susceptible to interference. This technology has the potential to revolutionize space-based communication, enabling us to transmit vast amounts of data between Earth and space, and even between satellites themselves. As we venture further into the 21st century, we can expect to see even more groundbreaking advancements in satellite technology. From space-based internet to interplanetary communication networks, the possibilities are truly limitless. So buckle up and get ready for a future where staying connected knows no bounds.